in this question, we've got a box that's being pulled by a student at this angle, 25 degrees above the horizontal, with 185 newtons. Now, this box is on a floor where there's friction. Okay, the box is 35 kilograms. But there's friction, and the friction, coefficient of friction, which tells us how rough the two surfaces are, and it's given by this symbol, mu, is 0.27. It tells us how rough the surfaces are. So we want to find the acceleration of this box. So the first thing we want to do is notice that there's forces. So if I draw a free body diagram, it might help us. So here's our box. There's gravity. Force of gravity is down. It's on a surface, so there's a normal force up. And then it's also being pulled. So I can call that my tension force, force of tension, or you can call it force applied. And because there's friction, friction's going to resist its movement. Okay, so there's my free body diagram. Now, if I say that this is my y direction and this is my x direction, I've got to look at my forces and say, okay, are they in the x or in the y direction, or a little bit of both? So this will be in the x direction, negative y direction. I should say negative x direction, negative y direction, positive y direction. But tension force has a little bit of both. It's got both x and y. So what we got to do is we got to take that force of tension, which is 185 newtons, and we've got to break it up into the x and y directions. We'll see why this is going to help us. Okay, so this is a right angle triangle. Whenever there's a right angle triangle, we can use SOHCAHTOA. So we can label this our x side and our y side. So if I want to find what the y side is, sine 25 degrees, my opposite is y, my hypotenuse is 185. Get y all by itself. Put that in our calculator and we get 78.2. Try the same with the x and you'll find, using cos 25 degrees, it's x all over 185. And we solve and find x is 167.7. Alright, so now we look at our forces. Are they all in the x or y directions? We got this one x, y, y, and this one's now broken up in its x and y directions. So we can create a table for the x and y directions. So, for a table, let's sub in our forces. Let's look at our first one. Force of friction. Force of friction is in the negative x direction, and it has no component in the y direction. Force of gravity is in the negative y direction. It has no component in the x direction. Normal force is in the positive y direction with nothing in the x direction. And our last one, tension, we have both the y directions and the x direction. .2 in the y direction and 167.7 in the x direction. Our next step is to add up all of these forces. The net force tells me the addition. In the x direction, so all I did for both of these were added this plus this, so you could have written it the other way around. Negative FF plus 167.7, or you could have written 167.7 minus FF. It's the same thing. Over here, I decided to write force of gravity first. So remember what we're trying to find. We're trying to find the acceleration of this box. Okay. Now let's visualize the box here. The box is moving to the right. It's not moving up or down. So the acceleration is going to be in the x direction, the positive x direction. It's going to be the acceleration. So if I want to know my acceleration, I should probably look in the x direction. Now Newton's second law is this relationship. F net x is equal to ma x. So if I add up all my forces in my x direction, I can find out what my acceleration is. So let's try that, see what happens. F net x is equal to ma x. Let's go back, see what our net forces are. Well, here's my F net x. 167 minus force of friction. Is equal to mass times my acceleration. Now we're trying to find what this is. This is our goal. Put a big square around it. This is what we're trying to find. All right. So let's try to put in what we can, what we know here. All right. I just wrote on the side here some definitions that we'll need. We'll talk about this one first. Force of gravity. Force of gravity is mass times this gravitational constant, g. Force of friction, we learned, depends on the roughness of the two surfaces, so your coefficient of kinetic friction, and the normal force. So let's go ahead and see if we can finish up this question. My force of friction, I'm just going to sub in mu times Fn for force of friction. They're the same thing. So let's see if we have these numbers. Go back to our question. Our coefficient of friction is, our coefficient of kinetic friction is 0.27. I don't know what my normal force is. I'm not sure what it is at this time. Our box has a weight of 35 kilograms. Okay, so we're stuck. We need to know what the normal force is, but we're not sure what it is yet. Okay, so now is what we have to do is we've looked in the x direction. Let's look in the y direction to see if we can find what the normal force is. So we're going to do the same thing for the x direction as we did or we're going to do the same for the y direction as we did the x direction. F net y is equal to MAY. Now, there's one thing we've got to notice here, right? Our box is accelerating in the x direction. That's the direction of the acceleration. It's not accelerating in the y direction. We don't see this box levitating off the ground as it moves. It's just going to move straight in the x direction, not in the y direction. So my acceleration in the y direction is equal to 0. We're not accelerating in the y direction. This acceleration is 0. That'll help us out solve this question. So 0 times any number, well, that's just 0. So this whole right side of the equation is 0. So what this is saying is if I add up all my forces in the y direction, F net y, I should get 0. So let's look at our forces in the y direction. We've already written them down right here. I'll write them out again. Negative Fg plus Fn plus 78.2. That's our F net y is equal to m times 0 is just 0. Now let's sub in what Fg is. I've written it up here to help us out. Mg plus Fn plus 78.2 is equal to 0. So we're going to sub in whatever numbers we know now. Again, we said the mass was 35 kilograms. So this is 35. Gravity is 9.8. Okay, we're not going to put negative 9.8 here, because what happens if we put negative 9.8? Let's just see for a second here. If I made this negative 9.8, then I would get negative, negative. This whole thing would be positive, meaning this force, the force of gravity, is up. We know the force of gravity isn't up. The force of gravity has to be down. So with our coordinate system, the force of gravity, this entire term, has to be negative. So the negative that we usually put in front of the 9.8, that's going to go. That's found out front. When we decided what direction to make gravity, we included the negative there. Plus Fn plus 78.2 is equal to 0. So now let's get Fn all by itself. So you isolate for Fn, get Fn all by itself, calculate the numbers, and you should get 264.8. So we're almost done. What we're going to do is we're going to take this number and sub it into equation 1. Once we subbed in for Fn, all we have to do is isolate for Ay. So these are going to be our next two lines. Sub it into equation 1 for Fn, and our left side of the equation is going to be 96.2. So our last line, we just have to divide both sides by 35. So we get Ax is equal to 96.2 divided by 35. That gives me 2.75 meters per second squared. So let's quickly review what we did here. We drew our free body diagram. We split up our forces in the x and y direction. We put them in the table. Then we tried to look in the x direction, got stuck, and had to look in the y direction.